All right, we're going to finish the system of equations today. Go back over some of the harder ones that we did on Tuesday, and then get into some like word problems, but it won't take too long. There are three different ways to solve the system of equations. We can graph them and see where they intersect. So we're looking at the point of intersection. That's our answer. That works better with technology than it does by hand. We saw that the other day. The substitution way works really good when you have a variable that's already solved by itself, like this y right here is already by itself. So you can take that 2x plus 4 and put it in for the y. But the way we end up using the most of the time, because it does work for so many types of equations, is the elimination or the addition method. So we're going to go back over that today and, like I said, do some word problems. But this one, so we can, like we did the other day where we manipulated it, we had a -2 and a +4. So we multiplied this one by 2 to make this a -2. So it was 4 plus -4, which made it cancel out. So we want to manipulate the equation to make one of the variables cancel out. It does not matter whether you do the y's or the x's. You can do either one. We'll try to do a variety of each of these. So when I look at my x's right here, when I see 2 and 3, the first number that comes to my head is 6. When I look at my y's right here, the first number that comes to is 15. So I'd probably rather do the x's because 6 is smaller than 15. That's only the real reason why. So I need to make this 2x be positive 6x, and I need to make this 3 be negative 6x. Okay, so what I'm going to do is I'm going to multiply the top one by 3. So 3 times 2x is 6x, 3 times 3y is 9y, 3 times 11 is 33. And then I'm going to multiply, I need this one to be negative 6x, so I'm going to multiply it by -2. So you want a positive and a negative, so when you add them up, they cancel out. So -2 times 3x is -6x, -2 times 5y is -10y, and -2 times 18 is -36. The most common mistake when you do these on your own is to forget to multiply that last number because it's on the other side of the equal sign, but you do have to multiply the entire equation by whatever you're changing it to. So now I can add these up. 6x minus 6x cancel out. That's good. That's what we wanted. 9 minus 10 would be -1y, and 33 minus 36 would be -3. If you ever get down here and you have an x and a y still, then you did something wrong. You want to make sure one of the variables cancel out. So I divide by -1, and I get y equals 3. So now I'm going to take this, and once you get one answer, you just plug it in to get the other answer. You can plug it into any equation you want to. I'll plug it into the top one. It's a little smaller numbers to work with, I guess. So 2x plus 3, I'm putting a 3 in for y, equals 11. So 2x plus 9 equals 11. Subtract 9 from both sides. Divide by 2, and x is 1. So these intersect at the point 1, 3. All right, this one right here, the x's and the y's. When you look at this, which one do you want to cancel out, the x's or the y's here? The x, okay. I think last class chose x too. I probably would have chose y because they're different signs, but that's fine. We'll do x. So we want to make it be what? Positive 18x and negative 18x. So my negative 9x, I want it to be positive 18x. So I'm going to multiply it by -2. -2 times negative 9x would be positive 18x. -2 times negative 8y would be positive 16y. -2 times negative 9 would be positive 18. And then to make negative 2x be 18x, I'm going to multiply it by 9. 9 times negative 2x would be negative 18x. 9 times 3y would be 27y. 9 times negative 2 would be negative 18. So So when I add these up, 18 minus 18x, 18x minus 18x cancel out. 16 plus 27 is 43. 18 minus 18 is 0. 18 plus negative 18 is 0. That is fine. 0 is a number. Like, that does not mess with anything. 0 is a number. So when we divide by 43, 0 divided by anything is 0. That's fine. It's okay to get 0. So now once you get one answer, plug it in. So I'll plug it into the bottom one just because, like I said, I kind of look for the smaller numbers to work with. Maybe something with less negatives. So 3 times 0 cancel out. I get negative 2x equals negative 2. Divide by negative 2. And x is 1. So these intersect at the point 1, 0. So it is fine if you get 0 for an answer for one of the variables because that's still a number. All right, there are a few weird scenarios that do happen, though, so let's go through these real quick. So on this one, if you want to cancel out the x's again, we would multiply this by negative 2, right? So negative 2 times 2x would be negative 4x. Negative 2 times y would be negative 2y. Negative 2 times 3 would be negative 6. Sorry, I didn't give you a second to write it. So now when I go to add these up, 4x plus negative 4x cancel out. Well, 2 plus negative 2 cancels out, so I have nothing on this side. And 6 minus 6 also adds up to be 0. Well, this is a problem because now I don't have a variable. So when 0 does equal 0, we know that's correct. What they say is this is infinitely many solutions. That means I have an infinite amount of solutions. That is because these are actually the same line. Like, I draw one of these lines, and then I draw the other line right on top of it. So these actually mean these are the same line. So that creates an infinite amount of intersections. Like, they're always touching, there's an infinite amount of answers. So actually any number that I pick, any number that works for this one would also work for this one, or vice versa. So that happens when you get 0 on both sides, when you end up with 0 equals 0. On the next one, if you want to cancel out your y's, I need this to be positive 3y, so I'd multiply it by negative 3. So negative 3 times x would be negative 3x. Negative 3 times negative y would be negative 3y. Negative 3 times 4 would be negative 12. So here we're trying to cancel out the y's. So I need a positive 3y, so I'll multiply by negative 3y. When I go to add these up, 3x plus negative 3x cancel out. Negative 3 plus 3y cancel out, so I have nothing on this side. 6 minus 12 would be negative 6, or 6 plus negative 12. So 0 does not equal negative 6 here. This is no solution because it doesn't come out equal. What happens here is I actually have parallel lines. These lines never intersect, which is the definition of parallel lines. So there is no answer. There is no one point that would make, there is no point of intersection. So there's no point that lands on both of these lines. All right, next is some word problems. These word problems aren't too terrible. There's a bad word problem next week, but we'll deal with that next week. So the sum of two numbers is 15. The sum means to add. So if I take one number plus a different number, it equals 15. And it says, and the difference is 3. The difference is subtraction. So if I take that same number minus the second number, it would be 3. Now you probably could, with numbers like 15 and 3, probably guess and check this and try to think about what adds up to be 15 and subtracts to be 3. But you can set up a little equation like this. Anytime we do word problems, like the reason you have to take math is to develop your critical thinking skills and problem solving skills and things like that. So like anytime we do a word problem, I try to do the algebraic plus like just thinking through it. But this one, like you could guess and check this one really. So on this one, the positive y and negative y already are there. So you have positive 1y minus 1y. Those cancel out. So I get 2x equals 18. Divide both sides by 2, and x equals 9. And again, just like before, once you get one answer, plug it in. I'll plug it into the top one. Oh, wait, our x is 9. We're trying to figure out what y is. So we subtract 9 from both sides, and y is equal to 6. So this is, my first number is 9. My second number is 6. 9 plus 6 is 15. 9 minus 6 is 3. So on these problems, you do have to set up your own equation or two equations and then solve them. The next one's a little tougher, but shouldn't be too bad. They all kind of have the same setup here. All right, this one, a store sells 2 pens and 3 notebooks for $13. So you always just have to define what you're looking at here. So let's make our X be pens and our Y be notebooks. So if I sell 2 pens, I don't know how much they cost, plus 3 notebooks, don't know how much they cost, but I know that they added up to be $13. 2 pens plus 3 notebooks added up to be $13. So I did that one day, and then I went back and I got 1 pen plus 2 notebooks, and it added up to be $8. So if I went to the store twice and I didn't know how much each one cost individually, I could figure it out with these two system equations. Now the reason this works, and I haven't really said this yet, but the reason you can always solve these is because you have 2 variables and 2 equations. You can always solve that. So it always matches up like that. If you have 3 variables and 3 equations, you can solve it. Or 4 variables and 4 equations, like you can solve it. So it always does work like that. All right, so we want to cancel something out. It's always, we could use substitution and just solve for x and plug it in, but I know y'all like the elimination method, so let's make this be negative 2x. So we'll multiply this one by negative 2. Negative 2 times x is negative 2x. Negative 2 times 2y would be negative 4y. Negative 2 times 8 would be negative 16. Do not forget to multiply that last number, whatever that past the equal sign. So now I'm going to add up the top and the bottom one, so I'm not really looking at that one anymore. So 2x minus 2x, those cancel out. 3 minus 4y would be negative y. 13 minus 16 would be negative 3. And then to get y completely by itself, divide both sides by negative 1, and y equals 3. So now, again, that's my notebook cost, so we got to find the pen cost by plugging it in. I'm going to plug it into that one I crossed out, actually. X plus 2 times 3 equals 8. So x plus 6 equals 8. Subtract 6, and x is 2. So my pens are $2, and my notebook were $3 each. All right, the next word problem is a little, I will say this before I leave this problem. The one they like to ask, which is the same thing, is if you have like, if you go to a concert and the adult tickets cost this much and the kids tickets cost this much and you pay this much total, how much does each of them cost? Or you buy 2 adults tickets, you buy 3 kids tickets. It's going to work the same setup as this like notebook and pen one though. The other word problem that we have in this section, they give you a chart, so it actually makes it super easy for you. Rachel rented some movies and video games last month. She did the same this month. The table below shows the number of movies and video games she rented and the total cost. Let X be the movies and Y be the video games. So to set up the equations, you really just write down the chart. Basically, you have 2 movies plus 6 video games equaled $42. So I'm looking at the columns here. And then I have 5 movies plus 3 video games equals $30. So you do have to be careful, like which way you're looking at these, because of like this one, we're looking at the columns. Like my X is the first row, my Y is the second row, the total cost is the third row. So you're kind of looking down. I believe on the next one we kind of look sideways, so you do have to pay attention to that. But it should look pretty much just like the chart when you get done writing it. So I think it'd be easier to cancel out the Y's here and make this one be negative 6Y, because if I do the X's, I'd have to multiply both of them to make them both be 10. So we could just multiply this one by negative 2. So negative 2 times 5X is negative 10X. Negative 2 times 3Y is negative 6Y. Negative 2 times 30 is negative 60. All right, so I'm going to, again, add the top and the bottom, and I'm sorry that I write it like this. It just saves you a bunch of writing. You can just rewrite that if you don't like the look of that. But I'm adding the top and the bottom one. 2x minus 10x would be negative 8x. 6y, negative 6y cancels out. 42 minus 60 would be negative 18. Now, I have said that Alex is pretty good about not giving you decimals on these problems. On this topic, they do give them to you a little bit because of our fractions, because we're talking about money, okay? So when I divide by negative 8 here, I get x equals 2.25. I would just change it to a decimal. We're talking about money, so that's $2.25. It should be a nice decimal like that. It shouldn't be something crazy. So now, again, once I get that answer, take it and plug it in. So I'll plug it into the top one. So the movies cost $2.25, or 2 of them, so that'd be $4.50. Then you subtract $4.50 from both sides, and again, you can use a calculator for this, and it doesn't make it bad at all. That's 37.5. Divide by 6. And that is $6.50. So my movies were $2.50. And my video games were $6.50. All right, last word problem, and then the last topic's pretty easy. A store is having a sale on walnuts and chocolate chips today. The table below shows the amount of each type of food and the total cost of 2 purchases today. So this one, we are looking at like the rows here. So let X be walnuts and Y be chocolate chips. So 12 pounds of walnuts plus 2 pounds of chocolate chips equaled $25. So this one's going just straight across. The last one we kind of did the column. This one we're doing the rows. So 3 walnuts plus 5 pounds of chocolate chips equaled $22. So again, just pay attention to when it says X is the walnuts and Y is the chocolate chips, and that helps you make sure you know if you're looking at the columns or the rows. On this one, I think the x's may be easier to cancel out because we only have to multiply this one by -4 to get -12x. The -4 times 5y would be -20y, and -4 times 22 would be -88. Do not forget to multiply that one at the end. So add these up. 12x minus 12x, those cancel out. 2 minus 20. We're not looking at this one. We're just looking at the top and the bottom. 2 minus 20 is -18. And that would be -63. So again, since we're talking about money, I bet we get a decimal. That's 3.5. So the walnuts are $3. Oh, no, I'm sorry. Y is chocolate chips. Y is chocolate chips. Chocolate chips are $3.50 per pound. So to figure out the walnuts, we need to take that and plug it back in. So 2 times 350 is 7. Subtract 7 from both sides, and I get 18. Divide by 12, and x is 1.5. So our walnuts are $1.50, and our chocolate chips are $3.50. And again, if you're on a test, I don't know if I've really said this yet, but if you're on a test, you can always take these numbers and plug them back in. Like if you plug the $1.50 in for the x, plug the $3.50 in for y, and it should equal 25 on this one, and then you do it on this one, it should equal 22, and then you know you got it right. So you can do that on a test to double check your answer. All right, the last one, it's not a pretty picture, but I think something about the website, but it won't let me draw on the picture and it won't show up, so I want to make sure. This one's actually a pretty easy topic. It just says write the system of linear equation given a graph, so it's kind of going over back what we did the other day. But my red line is at, the y-intercept is at 4. Okay, so the red one has a y-intercept of 4. The slope of, what's my slope? If I count it up, I go up 1, 2, 3, 4, 5, 6. So it's 6 over 1, 2, 3. 6 over 3 is 2 over 1 or 2. So my red line is y equals 2x plus 4. So 6 over 3, again, what that means, I could have went up 2 to the right 1. 2 to the right 1. I know my drawing's not perfect, but 2 to the right 1. It's the same thing as 6 over 3. And then my blue line, my y-intercept is -3. And my slope here is down 1 to the right 1, 2, 3. So I went down 1, so I do -1 to the right 3. So y equals -1/3 x plus, nope, minus, because -3. So this is my system of equations. And we can also look at this and say that the solution to this system of equations would be at, what, -3, -2? I don't think they ask you for that, but the point of intersection would be the solution for that system of equations. So this one, you just got to read the graph. All right, and the last one here, do it real quick. Again, my red line, the y-intercept is at 3, and I go down 1 to the right 1, 2, down 1 to the right 1, 2, so it is -1/2 x plus 3. And my blue line, my y-intercept's way down here at -6. My slope is way up there. 1, 2, 3, 4, 5, 6, 7, 8. To the right, 1, 2. So 8 over 2 would be 4. So y equals 4x minus 6. So that means I could go 1, 2, 3, 4 to the right 1. And that would be a point, 4, 1. So that is my system of equations. And again, I don't think they ask you for this, but the solution is the intersection point at 2, 2, 2, 2, 2.